very easy to work out how to do Pearson's on the computer, and this works if you're doing linear relationships. Remember, if you're doing linear relationships, you're probably not going to get very good engagement for your IA, but you can probably get very good other marks. So let's say we have two sets of variables, and often if you've got them from the website, you can just copy and paste them into Excel, so you don't actually have to manually put them into the calculator. So let's say we've got all of this, and we just put this all in like this. And what we want to do is we want to work out what Pearson's is. All you have to do on Excel is type equals Pearson's, open the brackets, you select Y, then you select X, press enter, it gives you the Pearson's number. If you then change one of the values so it makes more sense, you can see the Pearson's numbers changed a little bit. So that's Pearson's. You can then reflect on what that means in context. In context, that's a weak correlation, so there's not much correlation between the two variables. That's just briefly describing it, but reflecting upon it means, what does that mean for your experiment? The other thing we could do is we could do slope and gradient. So slope, you have to select the Y. And so slope is just the gradient of the line, but we write down slope rather than gradient. It's the same thing. And then we can also write down intercept. So again, we select the Y first, and then we select the X second. Now that then generates an equation of our straight line. So we could say the equation of the straight line is Y equals 1.38, X plus 11.2. And you can see I've rounded each to 3 significant figures. You can talk about the limitations of rounding as well. That's something you could also talk about. And then if we said the Pearson's was a bit stronger, so I'm going to make the Pearson's a little bit stronger now. You can see it's getting a bit bigger. Now I'm taking out some values. There we go. The Pearson's much stronger. If the Pearson's is quite strong, what you then can do is you can then substitute into the equation of the straight line. So you might say, well, I want to predict what happens when the Y or the X variable is a certain value. So let's say the X value is 100. So we're going to predict what happens to Y when X is 100. So you say 1.38 times 100 plus 11.2, and then say what that means in practice. So you would work out that to be 138 plus 11.2, which is going to be 159.2. But this is not going to get you a very good maths mark. This is still quite basic. So that's a really quick way of doing Pearson's on the calculator. Has anyone got any questions about that so far? No? Is that helpful? Yeah. Another thing you could do is you could talk about outliers. So this is a really important thing for your experiment. So let's say we changed one of these values to 112. We're going to clearly see that this is an outlier, but you have to prove it with the outlier formula. Can anyone remember what the outlier formula is? Well done. Yeah, and it's 1.5 interquartile range, Q1 minus 1.5 interquartile range. To create this into a box plot, then you'd have to have the quartile 1, and you can actually type in quartile and it'll do it for you. So we can do this, and we can say quartile 1. That's not worked, so I think I've typed in the wrong function. There we go.
Do you press shift or command when you highlight the different values?
You can do it. It often predicts what you want to do. So it says data and then quartile number. So let's say we wanted to create the Y data into a box plot. So let's say we wanted to work out quartile 1, 2 and 3. We're going to do quartile 1 there. And then I'm going to repeat. If you wanted to repeat the same thing, you have to put $signs so that when you copy and paste, it keeps the same range. So I'm just going to copy and paste this 3 times. And then we're going to change this to quartile 2. We're going to change this to quartile 3. And then we know what the minimum and maximum is, because you can also write min. And you can choose this. And you can work out the min. And then you can also work out the max. And I'm very good at Excel. I've made money selling Excel spreadsheets. So if you need any help with it, I can help you. Yeah, I make about £20 a year. Not very much. On teaching Excel spreadsheets. Then this is called a 5-figure summary. You can then do a box plot generator, but we're going to see with this box plot that it's going to look a bit strange. Okay, remember this is a 5-figure summary. If we did the 5-figure summary, it would look like this. It would be 3, and then we'd have 6.5, What if I miss from the drawing as well? 6.25.
But wouldn't it be because it has like a big exponential growth?
No, it's not to do with the growth. It's to do with the fifth part of the data being very, very large. So that we would consider that visually an outlier. But you've got to mathematically prove it's an outlier. You can't just say, oh, that's an outlier because it's too large. So what I mean by that is we've got, sorry, this box plot is very dodgy looking. We've got 3 is the minimum, 6.25 is quartile 1, 9.5 is the median, 13.5 is the upper quartile, and then we've got 112. That's way beyond any of the other values, so it is going to be an outlier. So the way you work out outliers is by using these formulas. So you need to work out the interquartile range. So the interquartile range is going to be the difference between what? Does anyone know what the interquartile range is? It's going to be the difference between quartile 3 and quartile 1. Well done. This is all useful for your exams anyway, what I'm doing on the board. And then you get the interquartile range, and to use times, you just use a star. So you do the interquartile range times 1.5 plus quartile 3. And then that would say anything larger than 24.375 is an outlier. So anything larger is an outlier, and then you could do the same for the smaller. So I'm going to copy and paste this. I'm going to do 1.5 times the interquartile range, which is 7.25. But this time we want to minus it from the quartile 1. So we're going to do quartile 1 minus this. And anything smaller than minus 4.625 is an outlier. So Gleb, if we have a look at these two values, 24 and minus 4, what's an outlier out of this list?
I assume 112.
112, excellent. So what you get really good marks for engagement in your IA is if you repeat the process, if you say, I'm going to do this whole experiment again, but I'm going to cross out the variable to do with 112 because I can see that's an outlier. Please don't talk. So what we're going to do is we're going to copy this data above and we're going to repeat the whole experiment again. So we do all of these different steps again and we see how it looks different. You get really good reflection for this. So I just paste it down here. You can see that the Pearson's now changed from 0.79 to 0.877. Is that better? Is that Pearson better? Excellent. We can see that the slope is probably a little bit different. You just check the variables. You might need to change it because it's not quite as big anymore. Change it to 46. And again, we need to do the same for the intercept. And you can see now that the straight line is going to be changed slightly. It's going to be 3. It's going to have a steeper gradient, actually. Shh. And then what you do is you'd rewrite the gradient. You redo the substitution. You don't need to do the outlier formula because you've already done those. And you can see now the box plot is going to be slightly different. And actually, we've got 16 as the maximum and there's no outlier. So this is the kind of maths you have to do at minimum if you want to get a grade 3 or 4 out of 6 for the maths. You have to really ideally go beyond this by doing a chi-squared test and really go deep into your reflections of what this means. So that took quite a long time. Has anyone got any questions about that?